Hey everyone, and welcome to This Explainer. We're jumping right in today because we need to talk about one of the most pervasive and honestly, most dangerous assumptions in cloud architecture right now. When we talk about building resilient systems in the cloud, there's this massive misconception floating around, and it could literally cost a business everything if they aren't paying close attention. We're going to break down exactly what this trap is, and more importantly, how to fix it using data straight from our sources.
So, consider this quote. Many architecture discussions treat high availability and disaster recovery as interchangeable. They are not. That right there, that's the central thesis of our whole explainer today. In boardroom meetings, engineering huddles, architecture reviews, people just toss these two terms around like they mean the exact same thing. But conflating them, that is a huge trap. Thinking you have true disaster recovery just because your app stayed up when a single server crashed gives you this false sense of security, and we really need to shatter that right out of the gate.
Okay, I want you to basically burn this rule into your memory. This is the core mantra we're going to keep coming back to today. HA, or high availability, handles failures. DR, or disaster recovery, handles disasters. They are two totally different superheroes answering two completely different 911 calls. So let's break down exactly what each of these heroes actually does, starting with our first line of defense.
Section 1. What is high availability? Keeping services running during failures.
All right, let's dive into this. High availability is designed to keep services running when components fail, which minimizes your downtime. Now, notice the focus on that word, components. We're talking about, a hard drive dying, a network switch getting a bit fussy, or maybe a single application instance just flat out crashing. The main goal of HA is continuous service availability. It's kind of like having a spare tire on your car that's already rolling on the ground while you're driving. If one tire pops, no big deal, the car just keeps right on moving. So, what does this actually look like out in the wild? Well, everyday HA functions include things like multi-zone deployments, load balancing, redundant infrastructure, automatic failover, and continuous health checks. Just imagine a massive influx of users hits your app. Your load balancers automatically distribute that traffic across multiple, healthy, redundant instances. And if one instance fails a health check, boom, automatic failover instantly routes traffic right away from it and over to a working instance. The user clicks a button, the page loads, and they have absolutely no idea a server just caught fire behind the scenes. That's the magic of HA.
Section 2. What is disaster recovery? Recovering services after catastrophes.
Now we shift to disaster recovery, which is designed to recover services after major disruptions, basically restoring your business operations. While high availability focuses entirely on just keeping the service available, DR is completely focused on true business continuity after absolutely everything goes wrong. Think of it this way. HA is about avoiding downtime for those minor bumps in the road. DR acknowledges that the entire road just got washed out, the whole system is totally offline, and now it is a frantic race against the clock to bring the business back to life. The events that actually trigger DR are, quite frankly, catastrophic. We're looking at things like regional cloud outages, severe data corruption, those terrifying ransomware attacks, large-scale infrastructure failures, or just complete infrastructure loss. To survive these nightmares, DR relies on heavy-duty tools. We're talking immutable backups, system snapshots, and continuous data replication to an entirely separate secondary geographical region. You aren't just routing traffic to a new instance here. You are literally rebuilding the whole environment.
Now, what's really interesting here is looking at the macro view of these architectures side by side. Over on the HA side, it operates locally. You've got a load balancer distributing users across Zone A, Zone B, and Zone C. So it's highly redundant, sure, but it's all sitting in one primary region. But look at the DR side. It steps way back to a global view. You have that entire primary region continuously replicating its data to a totally separate secondary region. If the primary region literally gets wiped off the map, failover activates, and that secondary region takes the wheel.
Section 3. Key differences in metrics, a head-to-head comparison.
Contrasting their overarching objectives directly shows us a fundamental mechanical difference. The goal of HA is to minimize downtime, while the goal of DR is to restore business operations. Keeping a service available while one tiny component fails is just not the same thing as restoring an entire system from scratch after a massive catastrophe. One strategy keeps the lights on, the other rebuilds the whole power plant.
When we measure the specific metrics of survival, just look at the scope. HA is local, within a region or zone. DR is regional or even global. But I really want to draw your attention to the downtime row here, because this is a stark contrast.
With high availability, you expect downtime to be measured in seconds, maybe minutes at the absolute worst. But with disaster recovery, you're measuring downtime in hours, or potentially much, much longer. You'll also see data loss down there at the bottom. HA usually means minimal data loss, whereas DR data loss is defined by a specific metric called RPO, which actually brings us to some absolutely critical definitions.
When you're planning for a disaster, you basically live and die by two acronyms. The first is RTO, or Recovery Time Objective. This simply answers the question, how quickly must services recover? Is your business okay being offline for 4 hours, 24 hours, a whole week? This time-bound metric is driven entirely by your disaster recovery planning, and it strictly dictates how much you're going to need to spend on your secondary infrastructure.
The partner to RTO is RPO, or Recovery Point Objective. This one answers the question, how much data loss is acceptable? Look, if you take backups every 24 hours, and a disaster strikes right before that next backup is scheduled, you lose a full day of data. Can your business actually survive that? If not, your RPO needs to be a lot tighter, which might mean setting up continuous replication. Make no mistake, these two metrics, RTO and RPO, dictate your entire recovery process.
Section 4. Why you need both. The synthesis of resilience.
It is a pretty harsh truth, but highly available systems can still have absolutely terrible disaster recovery. You can have the fanciest autoscaling groups, load balancers everywhere, a flawless multi-zone deployment. But honestly, all those redundant app instances won't save you if a ransomware attack encrypts your primary database and locks down the entire environment. High availability simply does not equal invincibility.
Let's move along and see how this builds in a real-world scenario. Step 1. You've got a Kubernetes cluster spanning multiple zones. Awesome, this provides excellent HA. If a pod crashes, another one spins right up. But then, step 2, an entire cloud region fails completely. Maybe it's a massive power grid failure, who knows? But now, your HA setup is completely offline because the whole region is dead. That's exactly when step 3 kicks in. Disaster recovery mechanisms activate to restore the system in a totally different region. The HA handled the local issues flawlessly, for sure, but it took DR to step up for the big regional blackout.
When you deploy both of these architectures as teammates, rather than treating them as substitutes, the business value is just undeniable. You achieve true end-to-end resilience. You protect your revenue and your hard-earned reputation. You can easily meet those strict compliance regulations and SLAs. You guarantee stronger business continuity, and ultimately, you earn better customer trust simply because you are prepared for absolutely anything.
So the crucial takeaway is this: keeping the system running and bringing the system back from the dead are two entirely different skill sets. I'm going to leave you with this provocative question to ponder as we wrap up this explainer. Your systems might be highly available today, but can they actually survive a disaster tomorrow? It might be time to audit your architecture and find out for sure. Thanks so much for joining me on this deep dive, and keep building resilient systems.